All right, so this week you guys are learning what we call measures of center, measures of variation, and I'm sorry if you can hear my dog barking in the background. Measures of center, measures of variation, and you're talking about like locations, so percentiles and things like that. I'm gonna do probably an example of each. I'll write out your formulas here real quick. I didn't get a chance to set them all up yet, but that's okay. Measures of center are your mean, your median, right? These are called measures of the center, your mode and your mid-range, because they all kind of measure what's happening kind of in the middle, in the center, right, of your data set, which, like I said, I say it all the time, like mathematicians, every term that we use, everything that we call a certain thing, vocabulary, it's just very direct, right? Measures of center, they measure and they talk about the center of a distribution. So the mean is now I'm going to talk about the mean in two different ways, okay? Your mean, you have notation that's coming up now, variables that you have to know and recognize. And first thing is for the mean. And I'm going to give you the formula for the sample mean, but because you guys aren't really doing calculating population mean, but it's very similar in terms of the formula. But you have notation for a sample mean and you have a notation for a population mean, and you need to know both. You can see my screen, right?
Mm-hmm.
Okay. Your sample mean is notated X bar, okay? X bar. So we say this out loud, X bar. You're gonna have to be able to recognize what X bar means when you see it. You wanna get really good with recognizing these variables. Population mean looks like this. This is called mu. This is a Greek letter that we use to indicate population mean. You need to know the difference between the two, because later on, if you do not know what the difference is, it's going to be harder. Start now getting used to the notation and converting it into what it is, in terms of sample mean versus population mean. And the mean we know is an average. So this is an average from a sample, which would be a statistic. And this is an average from a population, which would be a parameter, if you remember those terms from week 1, I think, right? So to calculate your mean, because you'll be given a sample, we'll calculate a sample mean X bar. You have the following notation. So you have this symbol, which I talked about last week in the Q&A. I don't know if you watch it or if you were there. Oh, I know you weren't there, but if you didn't watch it, then this means summation. Anytime you see this symbol, it indicates to take a sum. And so to take the sum of all the X, these are X, this is not X bar, this is X bar, this is your sample mean, this is X. That indicates each of your data value. This is your variable. Each data value, add it up, and then divide by n. I think everybody kind of knows that, but if you want to get used to the formula, which you should, because you'll see different variables in notation, then boom, that's it. Your median is the middle data value, the one right smack dab in the middle, and you need to have your data set in order from least to greatest. Has to be in order from least to greatest before you find that. And actually, it's called the 50th percentile. You might see that term. And then later, I think next week, we talk about quartiles. It's also the second quartile. The median is also the second quartile. I'll probably talk about quartiles today too. We'll see. But next week, for sure, you're going to talk about quartiles, which 50th percentile is the middle. It separates the lower 50% from the upper 50%. And I'll come back to that again too. Mode is the most repeated data value. And I don't know if we talk about bimodal or anything like that, but if I have bimodal data, then there's 2 modes. If I have multimodal data, I have more than 1 mode. But if every single data value is repeated the same amount of times, then there is no mode. Okay. And then the mid-range, you take the maximum data value, add the minimum data value, and cut it in half. All right, so let me start with these. And then I'll come back to, plug in my computer. And then I'll come back to measures of variation next. I'm probably going to use this for everything. I'm going to use this data set for everything, so let's just use it. This is from the homework. I think they asked for a percentile, but I'm just going to use it for everything. So I'm going to start with your mean. How many data values do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right. It's a good amount of data values. But I'm just thinking about entering it into the calculator. So we'll do it. So here's my mean. So this is a data set that I'm given. And let's say I'm asked for the measures of center. So I want my mean, my sample mean, my median, my mode, and I'll do my mid-range. Okay. So let's start with the mean, which we know we take the sum, right? So back to this, we take the sum of all the data values and divide by n, which is the total number of data values, right? That's like your sample size. So I'm going to take the sum of all these, 1400 plus 1700, all the way down to 8900. Add them all up, and we'll do it together. And divide by how many we have, and we have 1, 2, 3, 4, 5, 10, 15, 24. Total of 24 data values. So that's my n in this case, right? N is 24 data values. Okay, so there are actually two ways you could find a mean with the graphing calculator. I'm going to show you this way, which is going to be a good time because we have a bunch of these that we have to enter into our calculator, but we'll do it together. So 1400 plus 1700 plus 1800. So let's do it. 1700 plus 1800. Make sure we don't enter it wrong. Plus 2000 plus 24. 2400. 2635 plus 2600 plus 3500 plus 4300. You have your calculator out?
Yeah, I'm way ahead of you.
Oh, okay. Plus 4400 plus 5200 plus 5500. I'm catching up.
Yeah, you are.
Plus 5600 plus
No.
5700. I'm coming. Plus 59 plus 61. All right, 61. Right, and this is, you know, obviously the more values I have, the more annoying this could be, but 64, 66, I'm almost there. Did you finish?
Not yet. You keep blocking me.
Oh, sorry. 66, 74, 76, go ahead. Plus 76, 100, I got 79, 82, 84, 7900, 8200, 8400, 8900. You have it all?
Almost.
I caught up. All right. So that was it. Wait, make sure you have them all. And we're going to have to repeat writing all of them down, but I'll show you why in a second. Excuse me. So the sum of all of them, I got 125,800. 125,000, oops, 800. And then I want to divide that by 24. And I have my sample mean. Now, they're going to tell you how they want you to round. I think sometimes they'll say like 1 decimal, 2 decimal, you know, it'll vary. Let's just do 2. Typically, the round off rule is like 1 more than represented in your data set. So these are all whole numbers. So I would typically round to the 10th place, which is 1 more. Just pay attention to how they want you to round, okay? So if I round to the 10th place, let's say, that's here, I'm going to go, you know, everybody hopefully knows how to round, but you look over here. If this is 5 or more, then this goes up. If this is not 5 or more, then this stays the same, right? So 5241.7 would be 5241.7 would be my sample mean for this data set. Make sure you got the same thing. Okay. Our median is the middle data value. Now this is listed in the table, but it's least to greatest for me already. So if it was not least to greatest, I would have to put it least to greatest, or I would use my calculator and it can do it for me. And I'll show you that in the next set of problems, okay? But the median is the middle. And so if I have 24 data values, it's got to be smack dab in the middle. So what I like to do is divide 24 by 2. I get 12. So it's going to be between the 12th and the 13th. So if you have an even number of data values and you want the median, then it's going to be in between the two middle.
Okay.
If I had an odd number of data values, then you'll find a value that is smack dab in the middle. So here, let's do it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Here's the 12th data value, and this is the 13th, right? So it's going to be in between these two. Now, you could double check. Count how many data values are less than whatever I have in this blue area. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So whatever I'm going to put in this blue location, I have 12 data values less than that. So if it's the median, I should have 12 data values greater than that as well. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have the same amount of data values less and greater. So look, if I had like 9,000 here, then I would have an odd number of data values, and then I would actually have one of these that has the same number below it and above it. I wouldn't have to take the middle between two, okay? So it's a little different if I have an odd number of data values versus an even. Does that make sense? Okay, cool. So I have to find the middle between the 12th and 13th so that I have the same number of data values less and greater than my median is, the middle. So anytime you want to find the middle between two values, I mean, this is an easy one, but if it weren't, right, you add them up and divide by 2. It's like you're basically taking the average between the two. That's going to give you the middle between two data values. So when we do that, hopefully you get 5650, right? And I'll show you this real quick, because sometimes what happens if you don't put it in order, like on your graphing calculator, if you do this, check this out, right? It's not going to give me the right answer. And I want you to recognize that your calculator does order of operation. So if I do it this way, it's going to do division first and then do the addition. So if you want to do this, you can either put parentheses around the addition to say, calculator, do the addition first and then divide it by 2. Or you can just do the addition first, right? And then divide that value by 2. I wanted to show you that because a lot of times, if you just plug stuff in sometimes, you know, the calculator does order of operations, PEM does, right? So if I don't have parentheses around the sum, it would do the, you know, division first and then do this. So you get the wrong answer. You have to be careful with that, with, you know, plugging stuff in. So I just want to briefly touch base on that, just to make sure. So far so good. We're cool.
Cool.
All right. My mode, my most repeated data value. Go ahead.
I like math, so I usually understand it pretty good. So.
All right. As long as I'm making sense. My mode is my most repeated data value. And it doesn't look like anything here is repeated more than once, right? Everything is repeated the same amount of times. Nothing is repeated more than once, right? I don't see anything here that's repeated more than once. I'm going to move this for now. So in this particular example, there is no mode. Nothing is repeated more than all the rest of the values. And then the min range. We take the sum of the max and the min. So this is already in order from least to greatest, right? I'll show you the max plus min divided by 2. So this is already in order from least to greatest for me. So I know the maximum is 8,900. And then I add to that the minimum, which is 1,400. And I cut that in half to get my mid-range. So 8,900 plus 1,400. So again, you know, you be careful with your order of operations on your calculator. 5,150. So I did the 8,900 plus the 1,400, and then I divided that answer by 2, and I got 5,150. So these are my measures of center. So if I'm asked to find the measures of center for a set of data, this is what I have here. I just did that for this. set of data. All different ways to kind of represent the center, different ways to measure the center of a distribution of values, right? Okay, does that make sense? Not too bad, right? This is where measures of standard deviation, that is not what I meant to write there. This is where I love my graphic calculator. So I tell my students every semester, in stats, if you don't have a graphing calculator, and some like Desmos, and that's fine, but if you don't have some sort of something, right, and I love the graphing calculator, you know, you're gonna have a harder time. Not saying you can't do it, because you can. It's just that it's going to be a pain in the butt at certain points. Here's the first point, okay? Now, your measures of variation, right? They measure variety, obviously variation within your set of data. And, you know, you're gonna start to see a normal distribution curve. I don't think we've talked about it yet, but this is going to be your best friend. You're going to see a lot of normal distribution curve, and it's symmetric and it's bell-shaped, as we say. Anything that has this kind of distribution, if we graph it, where it goes low, high, low, it increases very similarly as it decreases, but the highest point is the center. This is called a normal distribution curve. I'm going to say ND, normal distribution. And you're, like I said, you're going to hear it over and over and over again. But so you're going to see typically the center of a normal distribution curve is a mean. It's your mean. If your data set is normally distributed, the center is the mean. So you could see, let's say these two distribution curves, they're a little bit different. This one is wider, this one is higher. So there's a different, there's a slight variation between the two. So how do I measure the variation within or comparing two data sets? We use these measures of variation, and standard deviation is a big dog. But you're going to have range, which is just the maximum value minus the minimum value, very simple formula. You're going to have your standard deviation, which is really important, really important. And you're going to have your variance, which you don't see a whole lot after this, but the variance is very easy because it literally is just the standard deviation, whatever that value is, squared. So once I have the standard deviation, I have the variance. But the most important measure of variation that you are going to see over and over and over and over is your standard deviation. And you're going to see it related to this kind of thing later on too. So I can say between these two, that these data values along this horizontal scale, you see it looks like there's more that are further away from the mean, because I have some all the way over here, let's say, and all the way over here. So I would say the variation is greater within this distribution that it is here, which would imply to me that the standard deviation is greater in this distribution than it is in this one. Right? So that's one way to talk about standard deviation. It is also always positive. Make sure it's always positive. Okay, always positive. And the larger the standard deviation, the greater the variation. Actually, let me write that. The larger the standard deviation, the greater the variation in your data set. Okay? The greater the variation. Very important. Also, on top of that, for standard deviation, and you're going to see me probably put this table out, just like the mean has a notation or a variable to represent the sample mean versus the population mean, so does the standard deviation, and you need to recognize them. You need to be able to see them and recognize exactly, oh, this is the sample standard deviation, this is the population standard deviation, just based on how it looks. So lowercase s is your sample standard deviation. And this is called sigma, another Greek letter that we use to indicate population standard deviation. So if I see sigma, I'm automatically talking about a population standard deviation. If I see S, I'm automatically talking about a sample standard deviation. Okay, very important, especially later on. This is a big deal. So get used to notation now. I tell you over and over again, okay? Now, I'm not going to use this formula for standard deviation because it's a pain in my butt, okay, honestly, right? We could cumbersome calculation. This is how you would do it. Now, I do have a video if you want to know how to do it with the formula. I have a video that I put out for you guys, and I'll It's in the announcements for my students always, and I'll put it in this chat too if anyone else wants to see. But you take each data value and you subtract from each data value the mean of them. Then, and I think I'm missing, I'm missing one thing. I forgot my summation here. Hold on a second, I'm missing something in this. I gotta take the sum and then this, okay, now I'm there, now I'm cool. Take each data value, subtract from each data value the mean, square those values, then add them up, then divide by n-1, then take the square root. That is how you calculate your sample standard deviation, or your standard deviation. Well, specifically sample standard deviation, right? Now that is annoying because if you have, like, look, even this one, I'm gonna use this data set. I have what, 5, 10, 15, 20, 24 data values. I would have to take each one of those and subtract the mean from each one of those and then square that number and, okay, ew, right? No, I'm gonna use a graphing calculator, okay? I'm gonna make my life easier. And I'm gonna use the graphing calculator to find my measures of variation. And I'm gonna show you something else that the graphing calculator gives me, because while I'm looking for my measures of variation, it's gonna give me some other information too that maybe I want later on, maybe I want now, I don't know. So let's find our measures of variation for this data set. And the first one is very easy, my range. So my range, and this is already in order from least to greatest, is just the biggest number, which is 8,900, minus the smallest number, which is 1,400. As simple as that. And again, just be careful how they want you to round. So what is that, 7,500? That's my range. And you're not going to see a whole lot of range after this, to be honest. My standard deviation, I'm gonna see a lot, and then my variance. My variance comes from my standard deviation. So once I get my standard deviation, I square it, I have my variance. So now it all rides on the standard deviation. All right, now, this is very important. Using my graphing calculator, I hate to say we're gonna have to input all these values into it, but anytime you wanna use a data set and you're gonna use it to calculate something in your calculator that you want it to run a program on, you have to put the list into your lists of data sets. So you're gonna come here a lot. You see stat? This is one of your favorite buttons on your calculator. Stat is right here in the middle, right next to this arrow. And when I press stat, you see this comes up. Now, I'm gonna actually do all this stuff by the end of the semester. You're gonna see calc, you're gonna see tests, but right now, we just wanna input these values into a list so that we can use that list to calculate stuff. So the first thing is edit. This is where I'm gonna put my list. So enter, or you could press 1, and you have all your lists come up. Now me, I have numbers already in mind, so I have to delete them. If you have numbers already in, then you be careful. You scroll up so that it's highlighted, and you press clear, enter. Do not press delete, you're gonna delete your list. Scroll up till it's highlighted, and then you press clear, enter. It'll clear the whole list for you. I would not press delete because that is going to delete my list. Now, if you're using an app, that's different. Sometimes the apps vary versus I'm talking about the graphing calculator, right? The physical one. So we need to put all of these into lists, and I'm going to put it in L1. Always remember where you put it. So we're going to input again these values. So let's do it. 1,400, 1,700. So let's do it. 1,400, enter. 1,700, enter. This is how I put values into a list. 1,800, 2,000, 1,800, 2,000, 24, 26, 35, 43, 44, 4,300, go ahead, 4,400. Aha, I'm beating you now. 5,200. Go ahead. Let me know when you get to 52. So obviously, you know, the more values there are, yeah, the more annoying it could be. However, doing this versus the formula is much different.
Sure.
You could do this stuff on Excel, you could do it on Desmos, but, you know, the graphing calculator is very, very user-friendly. You got it?
I do.
All right, 5,500, 56, 57, 59, 5,600, 5,700, 5,900, 61, 63, 64, 6,100, 6,300, 6,400. Make sure you put them in right. 66, 74, 76, 6,600, 7,400, 7,600, 79, 82, 7,900, 8,200. Oops, don't want a negative there. 84 and 89. 8,489. So I want you also to notice that we have 24 data values. So you see, like here, it says L1 and then 25, which is what this position is, which implies that there's 24 above it. So that's like a quick way to make sure you didn't miss anything. You know what I'm saying? And I might even like look up, make sure they're all like, they have 2 zeros, because I know they're all like in the thousands. So I have them all in, right? Let me go back to my home screen. Anytime you want to go back to your home screen, you see quit up here on top of mode. And then since it's in blue, I'd have to press second. So second, and then press mode to quit. And that's if you ever want to go back to your blank home screen, which sometimes is nice and comfortable. So again, if I want to input a list, I go stat and then edit, which is the first thing that comes up. And that's how I input a list of values into my data set. Stat, edit. Okay, now I want to calculate something with that. So I'm in stat again. I want stat again. But this time I want to calculate. See calc here? I want to calculate something. So scroll over with your right arrow to calc, and this is what it looks like. So you don't really need to use any of this stuff except for the first one, one var stats. That's all we're going to use. One var stats. Now, some of you have TI-84, some of you have TI-83s. The 84 looks like this, right? This is what your your screen looks like. Some of them, it just says one var stats and then like parenthesis blank. So you just have to, you know what to input. And all that you need to input is the list. And for me, my list L1 is already there. If it's not there, look on top of the number 1, you see L1. On top of the number 2, you see L2. On top of the number 3, you see L3. So you need to know where you put your list of numbers. And sometimes you're going to have multiple lists, but you can always tell it which one because that's where you pull it up. So if I didn't have this here, right, I would do second and then 1 so that L1 comes up because that's where I put my list. Frequency list, we're not going to do anything there. Frequency list is kind of like, so that's like if you have a frequency table. Your list would be the leftmost column and the frequency list would be like the rightmost column, the frequency of each value. We don't have that here. Down to calculate, boom, all this stuff pops up. And actually, I'm going to probably copy and paste this for your notes real quick. I'll put it in here because I'll give you guys these notes after. So this is what pops up, right? Actually, I want you to see too, you see the arrow? That indicates that there's more below. I'm going to even scroll down. I'm going to take that too. So all this stuff can be used. Well, we don't need it all right now, but I'm going to tell you what it could be for you. Oops, like that. Okay. So that's everything that pops up. So check it out. What's the first thing that it gives me?
X bar.
X bar, which is my
Sample.
My sample mean. It gives me my sample mean. So yeah, all right, cool. If I can't write the word sample. Okay, sample mean, right? Yeah, so if I don't want to like type it all out, then I could do it this way, right? If I'm going to use this for the standard deviation, then I might just do it this way, right? And find the mean also, or verify it. This is summation of x, which actually we did here, summation of x, right, as part of our mean. But you don't necessarily need this. You don't necessarily, this is used for other kind of things, but we don't need that here right now, or you don't need that period for this class. S, you see S versus sigma. Remember sigma, where is it? Sigma is my population standard deviation, and S is my sample standard deviation. And I want my sample standard deviation because that's what I calculated. It's my sample standard deviation, which in this case, 2327.7 rounded to the nearest tenth. So this gives me my sample standard. Without going through that whole formula, this is much faster. Even though, yeah, I put 24 values in my calculator, I get faster with that, right, as I do more of that. But yeah, rather than going through all this process, which is, you know, if I want to do it, I can. But I prefer this method.
I like it.
It gives population standard deviation, but we don't need that. N is my sample size, and we know that we have 24 data values, so that should match. That's a quick check. And remember I told you the median. It actually gives me the median too, 5650, which we found here. It gives me that as well. And if I didn't have, my data in order from least to greatest, I could use this method too, instead of putting it in order if it's a lot of data values, you know. If I put this into my calculator, it doesn't need it to be in order from least to greatest to give me the correct median. So if my data set's not in order and there's a lot of data values, I could use this method to find the median if I want, right? So it gives me my median too. And then actually next week, this whole thing is your 5-number summary. This is your 5-number summary, and you're going to use that for your box plot next week. So it also gives you something for next week. 5-number summary is used in your box plot, and it gives you your first quartile, Q2 second quartile, and Q3 third quartile, which you're going to hear next week. Minimum value, maximum value, that's your 5-number summary that you use for your box plot next week. But now you can do it here. It's not fun. It's not hard to find by hand either, but you know, it gives it to you if you want to do it that way. So, so we found our sample standard deviation, one of our measures of variation. This is 2327.7. My variance, now I could find that, which is my standard deviation squared. I wouldn't use the rounded one. I'd probably go back here and use 2327 and take a few of those digits and square it just for accuracy. Because if you round something too early and you're using a rounded value to calculate something else, you're going to have error in your final result. So if you're still calculating, don't round too early. Wait until you get to your actual answer. That's why I'm not going to take this value. I'm going to take the actual, you know, more accurate one. 2327, let me do that. 0.70024, and I want to square that. Oopsies. Now you're squared. You could do this button for squared, or if you have, let's say, an exponent greater than 2, then you can use this arrow, and then you could do squared that way too. 5, whatever the heck all that is. 541 8188 8188.4. And then again, just make sure you round how they want you to round and all that jazz. Okay. So these are my sorry, measures of variation. Okay. So far, so good?
So far, so good.
All right. There's a couple other things in this regarding histogram and things like that. If I have time, I'll do histogram. Histogram's not hard if you know how to deal with the frequency table, because it is a frequency table graphically. But I do want to talk about percentiles because I always get questions about percentiles. And they're not hard. It's just like, I think it's confusing at first. So percentiles, My son just came to get the Cheerios. I just felt this like wind of air. So percentiles, exactly what it sounds like. So K in this formula is your percentile. And, you know, for example, if I want to talk about, let's say, the 40th percentile, this indicates that 40% of the data values lie underneath my particular 40th percentile. 40% of the data values are less, let's say, than this, are less, and 60 or greater, 60% or greater, I'm gonna show you what I mean, are greater than the 40th percentile. So it is, if you are asked for a percentile, it is a location, right? What data value is in that location? Obviously, your data set has to be ordered from least to greatest again. But if I want, let's say, the 40th percentile, I'm talking about a data value that lies within the data set where 40% of the data values are less than that particular percentile and 60% are greater than that. So if it's the 20th percentile, 20% or less, 80% or more. If it's the 50th percentile, 50% or less, 50% or more, that's the same thing as the median. So this is my little locator formula. So this is the formula to find the location of a percentile. K is your percentile, N is your sample size, I is the location, and if I is an integer, that, I'm gonna say that is your exact location. But if I is not an integer, we're going to round down, write that number. I'm kind of just in it. I'll show you an example. Write that number, round up, write that number, and then take the average of the two. And that's the location. So let me go here and do this one. So let's say that I want in this one, the 44th percentile. Let's find that, okay? So to find the 44th percentile, I want to find the data value that lies 44% into the data set, if that makes sense. They're already ordered from least to greatest. That part is good. I'm going to use the locator formula. So if I want, oopsies, if I want the 44th percentile, my K is 44. My N, how many data? 5, 10, 15, 20. We had 24 data values, so N is 24. And I'm just going to go plug it in. So where's my? So I is equal to K over 100. 44 over 100 times, we'll go back to the formula, N plus 1. And my N is 24 plus 1. I mean, I could straight up go to, you know, I could go straight to my calculator with this, but I'm going to show my work too so you guys can see it. So 44 over 100 is 0.44. And I'm basically multiplying that by 25. So I get 10.56. Oops, I accidentally put 24 here, right? Yeah, I meant to put 25. 0.44 times 25, yeah. Don't make that mistake. 11. So my I is equal to 11 in this case. Now this is not my answer, this is the location. This is the location of the 44th percentile. It is the 11th data value. Now, back to this real quick, right? I said if I gave an integer, which it did, or I should say a whole number, it shouldn't really be negative, but if it gave me an integer, a whole number, that is the location of my data set. So this is the example where I go through the process, I go through the formula, and I get a number, a whole number, not a decimal. That is the location of my data value. So I need to now count to the 11th data value from least to greatest. 1, 2, 3, 4, 5. 6, 7, 8, 9, 10, 11. This is the 11th data value here. And so my 44th percentile is equal to 5,500. This is my answer. This is the data set, and you can always check it out, make sure. If you count your data values that are less than that, and divide it by 100, or divide it by your total 24, let me see, 10 under that, 10 divided by 24, right? Approximately. There's going to be a rounding error, but there should be approximately 44%, right? It's not perfect, but there should be approximately 44% below it. Oops. Oops. Okay, and approximately in this case, 56% above it. That's the location of this particular percentile. Let me do another one. Let's do, all right, let's do the 25th percentile, which is a special percentile. If I have time, I'll talk about it, but if not, that's okay. You talk about that next week again. The 25th percentile is what? So now in this particular example, my K is 25. That's the percentile that I want. The N, because it's the same data set as 24. I go back to my locator formula, right? I is equal to K over 100 times N plus 1. So K in this case, 25 over 100 times N plus 1. So I'm going to do, my dog, 0.25, which is 25 over 100, and then times 25. I think this one should give me decimal, 6.25. Awesome. So now when I get an I that is not an integer, this is what I'm going to do. I'm going to take that number, I'm going to round down and round up. So if I take 6.25 and round down, actually I'll write this out. Rounding down, I get 6. Rounding up, I get 7. So the 25th percentile is between the 6th and 7th data value. Does that make sense?
Right. Yeah.
This is probably the part that gets weird and funky when you get a decimal. So really all you do is just take the number in between the lower end and the high, right? Round down 6, round up 7, take between the 6th and 7th. So let's use red. So let's go back to my data set. 1, 2, 3, 4, 5, 6. So this is my 6th data value, and this is my 7th. So in between these two is my 25th percentile. Now, obviously I have to go in between two numbers again, right? So if I want to get the exact value in between two numbers, I have to add them and divide them by 2. Anytime I want to find the middle between two numbers, I have to add the two numbers and divide by 2. So 2,600 plus 3,500, it's like you take the average of the two numbers, right? And actually, 2,600 plus 3,500 and divide by 2, and I get 3050. 3050. So 3050 is my 25th percentile for this case. Okay. So does that make sense with percentiles? Not like crazy hard, right? But yeah, I think initially like it can be weird, I guess, right? Let's see if that came up. It didn't come up. So one more thing. Any questions about anything so far?
No, not really.
Okay, good. My
What
dog.
could be simpler?
Huh?
What could be simpler?
What could be simpler? I guess a lot of things could be simpler.
Right.
Don't worry, it'll get harder.
Yeah.
But it's okay. We'll make it through, right?
Yeah, we're good. Yeah.
So I just want to really quickly, just because you're going to see, hopefully you guys are good with your frequency tables. I'm going to make up a quick frequency table just to make my life easier real quick. I don't know. Let's just make that something, and this is the frequency. I'm making it up. So there's a frequency table. That is an ugly too. Sorry. Frequency 2, 3, 4, 5. Make this real easy. So this is a frequency table where I don't have ranges as my classes, right? I have values. So you can have frequency tables with ranges here or just straight up values. And then frequency, let's say, I'm gonna go 11, a 10. Let me do one more here actually. 10. Let's call it 12, 20, 13, 9, right? So this means that the data value 2 is repeated 10 times in my data set. The data value 3 is repeated 12 times in my data set, right? The data value 4 is repeated 20 times. So this is a frequency table, same idea as what we did last week. But you're talking about histograms this week. So histograms are basically frequency tables graphed. So I'm just gonna make a quick one. I'm gonna make it quick. So I have 2 axes here, X and Y. In this case, my X is whatever these data values are, whatever they are. If this is a range, I don't think you have to create a histogram though. I don't think you actually have to create it. But if this were a range of values, then the horizontal axis would either be the midpoint or the class boundaries. But because these are not intervals, then I can straight up just put them on here, right? So again, if this were a frequency table where I had intervals of numbers, then the horizontal scale is either going to be the class midpoint or class boundaries. Hopefully you remember those terms from last week. But in this case, these are not intervals, so this is just, it is what it is. So let's say 5, 10, no. 5, 10, 15, 20. I'll just count by fives. Okay, so a histogram is, I'm gonna make a histogram here. But a histogram is a frequency table, excuse me, graphed with bars of equal width. There are no gaps between the bars. Because it represents, each bar represents your class. And the horizontal scale, I'm not gonna write that because I wrote it here. The horizontal scale of your histogram will represent class midpoint, I'll leave it here, or class boundaries. So if it represents the class midpoint, then the middle of each bar would be the value here. If it represents class boundaries, then the ends of each bar would be along your boundaries. You'll see that in example, I think you have only one case where you have, you know, the histogram, but it's multiple choice, so it's actually not that bad. And I think it even tells you, yeah, use 85 to 89 for the first class. It gives you the class width and everything. So yeah, so again, if these were values, intervals, right? If these were intervals of numbers, then your horizontal scale is either going to be your class midpoints or your class boundaries. If it's your class midpoints, the middle of each value is the center of the bar. If it's the class boundaries, the ends. Start and finish each bar. And that's referencing question 3 on your homework. But that's easy to figure out. All right, so anyway, for my first bar is going to represent my first class, which has a frequency of 10. So I'm going to go up to 10. So I go, oops. So I'm going to go up to 10. And I'm going to have the center of this be 2 because this is not the class midpoint, but this is what it is for this particular case. So if I'm looking at a histogram and I'm reading it, I know that I have data set or data values here repeated this many times. This is my frequency. 3 is represented 12 times, so approximately here. Oh, I can't draw straight lines. 4 is repeated 20 times. I'm going up here-ish. 5 is repeated 13 times-ish. And 6 is repeated. You could probably hear my daughter. They're watching Blaze and the Monster Machine.
Oh, nice.
Do you know that show?
No.
Oh, it's actually really good. So I'll tell you, I'll tell you after. I know all the good educational shows. So all right, so this is my histogram for this particular case. So the horizontal scale represents my data values, and then the vertical scale tells me how many times each data value is showing up in the data set. So it's not hard, it's a frequency table graphed. But you can see now visually, if I were to like draw, for this particular case, like a curve following this, I would see that the distribution here is approximately normal. So I would say this is normally distributed or approximately normally distributed. If you ever see me write ND, normally distributed, low, high, low. So, I mean, I could see the distribution. You can kind of see it here too, because it starts off very similarly as it ends. It increases as it gets to the middle, it's the highest, and then decreases similarly as it increases. So I can see that there too. But the histogram is a nice visual of a frequency table. So anything that I can gather from a frequency table, I can gather from a histogram. So I just wanted to quickly show that because they talk about histograms, but probably one of the main questions I get from this week is percentiles, and then standard deviation by calculator. Everything else, not so bad. And then again, I'm going to stress to you and everyone that you need to get your notation down. Sample mean X bar, population mean mu, sample standard deviation S, population standard deviation sigma. Get used to recognizing variables. Get used to recognizing the notation. You're going to go back and forth between notation and verbal, interpretation of that a lot in statistics. So if you can understand and get used to that, it becomes much easier later down the line. So start practicing it now when it's not so bad, interpreting your situation. So like if these values were, I don't know, let's say these were, look at that, I don't know. Let's just call it time in seconds of something, right? So then my average, right, this 5241.7 would be an average time for this particular situation. You want to be able to convert whatever the notation is into words, as well as, the mathematical notation, speak math and speak words, right? Start getting used to it. Even if, the question doesn't ask for that, just start getting used to it because it's going to help you a lot later on. Believe me, believe me. That is one of the harder parts, I think, later on. I think that's what people struggle with the most when they get into like hypothesis testing and confidence intervals and things like that, because it's a lot of back and forth, interpreting what the notation means. Okay, so let me stop my recording and